Raabe's test. The statement of Raabe's test is summation un is a series of positive terms and let limit n tends to infinite n into un by un plus 1 minus 1 is equal to L. So here limit is L. Based on the limit we can say that is a convergent or divergent. Okay, if L is greater than 1 then you can say the infinite series is convergent. If L less than 1 the infinite series is divergent, and if L is equal to 1 test fails. Once again you see limit n tends to infinite n into un by un plus 1 minus 1 is equal to L. If L greater than 1 series is convergent, L less than 1 series is divergent. L is equal to 1 if you are getting, then it is a test fails. So whenever the test fails you can go for the Gauss test. When we will apply the Raabe's test means if ratio test fails then only we are going for the Raabe's test. Do you remember that ratio test what we have? In the ratio test is limit n tends to infinite un by un plus 1 is equal to L. If this L is equal to 1 then ratio test fails. Whenever it is L is equal to 1 then this one you take left side and multiply with n. Apply the limit which gives a Raabe's test. Okay. Once again I am repeating. Limit n tends to infinity un by un plus 1 is equal to 1 if you are getting. Test fails. Which test fails means ratio test fails. If ratio test fails, when ratio test fails means limit is 1. Take this 1 is left side. Then it becomes un by un plus 1 minus 1. Multiply with n and apply the limit. Generally, when the ratio test fails, we have two methods. One is a Raabe's test. Another one is Gauss test. And suppose if the limit is containing e, then in that case we can go for logarithmic test. This is about the Raabe's test. We will discuss problems in the next video. Okay. Test for the convergence of series 1 by 3 plus 1 into 4 by 3 into 6 plus 1 into 4 into 7 by 3 into 6 into 9 so on. Okay. This is the given series. It is given first term, second term, third term, fourth term. They are not given nth term. So we need to find out the nth term for the given series. To test the convergence, which one we required? Un only, na? So are they given nth term directly? No. So we need to find out the nth term. How we will find out the nth term means, you see, first of all, this is the fourth term. Now you remove this last term. So fourth term becomes a third term. Now you remove last term, so third term becomes a second term. Now you remove this term, then it becomes first term. So here if you want to find out the nth term, previous n minus 1 terms also you need to write. This is called the repeated series form generally. How we will find out the nth term means, see the common difference in the numerator. Common difference is here 1 4 means 3, 4 7 is 3. So common difference is 3. So write down 3 into n. Next, if you put n is equal to 1, you have to get the first term in this series. So put n is equal to 1 now. What we have? 3. But here it is 1. So I want to get 1 means just I am removing 2 from this. So 3n minus 2 gives 1. Next put n is equal to 2. This is 6 minus 2, 4. N is equal to 3, 9 minus 2, 7. Like this we are getting. So it is satisfying. Next in the denominator, 3 into 6 into 9 into 12. Common difference is 3. So 3 into n right down. Put n is equal to 1, 3. It is also 3, satisfying. Put n is equal to 2, 6, 6 satisfying. N is equal to 3, 9 satisfying. So this is the nth term. So to write the nth term in the repeated series form, we have to write previous n minus 1 terms also. Now, this is repeated series form. Which method you will apply generally means, go for ratio test. In the ratio test, you need to find un by un plus 1. So I know un, now I want un plus 1. How you will write un plus 1 term? It should contain nth term or not? Yes. Now, n plus 1 term means just you add the common difference and write the product. Write as the product. So 3n plus 2. What is the common difference here? 3. So 3n plus 3n minus 2, you add 3, then plus 3 minus 2 becomes plus 1. Next, in the denominator also, 3n plus 3. This is un plus 1th term. Un plus 1th term containing nth term. And write in the numerator and denominator common difference. That gives un plus 1th term. Now, un by un plus 1 I want. Further, you see, nth term this one, n plus 1th term. So, up to nth term are getting cancelled or not? 3n minus 2, 3n minus 2 cancel. 3n up to 3n cancel. Now, the remaining 1 by 3n plus 1 by 3n plus 3. So, write as a reciprocal which gives 3n plus 3 by 3n plus 1. Now, taking limit n tends to infinite on both sides, then numerator what we have? 3n plus 3. Denominator what we have? 3n plus 1. Both degree same. Whenever the degree same, you have to take a coefficient is the limit. That is 3 by 3. If you have a doubt, take n common, n getting cancelled. 3 plus 3 by n, 3 plus 1 by n. 3 plus 3 by n in the numerator, 3 plus 1 by n. As n tends to infinite, 1 by n goes to 0. This is 0, this is 0. So you will have 3 by 3. 3 by 3 is 1, which is limit. L is equal to 1 in the ratio test. If we know that if L greater than 1, series is convergent to L less than 1, series is divergent to L is equal to 1, test fails. So what we can say now? Ratio test is fails. When the ratio test is fails, you have like a Raabe test and a Gauss test, logarithmic test. Limit is containing here only 1. So go for Raabe test. In the Raabe test, you want limit n tends to infinite n into un by un plus 1 minus 1. So limit n tends to infinite n into what is un by un plus 1 we have? Un by un plus 1 is 3n plus 3 by 3n plus 1. Right on? 3n plus 3 by 3n plus 1 minus 1. LCM is here 3n plus 1. So 3n plus 1 is as it is. Now 3n minus 3n cancel. 3 minus 1 becomes 2. So 2n by 3n plus 1. Now apply the limit. Again what we have? Numerator is 2n, denominator 3n means same degree. Then n quotient is 2 in the numerator, n quotient is 3 in the denominator. So limit is 2 by 3. 2 by 3 means L again what? 2 by 3. Limit is 2 by 3. So what we can say now? L is less than 1. So L less than 1, which is Raabe test. From the Raabe test what we can say? Divergent. So the series is divergent by Raabe test. Since L is equal to 2 by 3 less than 1, so it is divergent by Raabe test. Test the convergence of the series 3 square by 6 square, 3 square dot 5 square by 6 square dot 8 square plus so on, like this is the given series. Now in this series, are they given nth term? No. So we have to find the nth term by the observation of this series. You see, this is first term, second term, third term. First term, the third term is containing second term. Is it or not? Yes. Second term is containing first term. Yes. So this is called repeated series form. We need to find the nth term. How we will find out the nth term means, in the numerator, what they are given? 3 square, 5 square, 7 square. To get the nth term, what is the common difference? 2. So write down 2n. 2 into n. Next, if you put n is equal to 1, we have to get the first term is here. If you put n is equal to 1, here you have 2. But the first term is here 3. So write down 2n plus 1. Now square. Put n, check it. Put n is equal to 2. 2 square, 2 into 2 means 4 plus 1, 5 square. Next 3. 6 plus 1 whole square means 7 square. Now I want to denominator. 6 to 8, 10. 6, 8, 10 means common difference is what? 2. So write down 2n. Next, what is the first term is here? 6. If you put n is equal to 1, what will happen? The first term is 2. So I want plus 4. Now check it here. N is equal to 2. 2 2 is a 4. 4 plus 4, 8. Yes, so square is required. 3. Put n is equal to 3 here. Third term you will get here. N is equal to 3 means 6 plus 4, 10. 10 square. Yes. So in the nth term we need to write in the numerator 2n plus 1 whole square. Denominator 2n plus 1. 2n plus 4 whole square. Each term common difference is 2 in the numerator as well as in the denominator. So it is a repeated series form. You have to go for, to test the convergence, we have to go for ratio test. Okay. In the ratio test, I want un by un plus 1 form. So for that I required un plus 1th term. That is n plus 1th term. So un plus 1. N plus 1th term, this is a repeated series form. No? So n plus 1th term is containing nth term also. Up to nth term write down. Next to just you add the common difference for the last term. What is the common difference here? You have 3, 5 common difference is 2. So add 2 for this term. So 2n plus 1 plus 2 gives 2n plus 3. Here common difference is 6, 8, 10. So common difference is 2. No? So add 2 for the last term. That gives 2n plus 6. This is the n plus 1th term. Now I want un by un plus 1. Un by un plus 1. By the observation, this numerator by denominator, this is containing up to nth term. No? So 2n plus 1 whole square, 2n plus 1 whole square cancel. 2n plus 4 whole square up to 2n plus 4 whole square cancel. Then this is reciprocal will become 2n plus 6 whole square in the numerator, 2n plus 3 whole square in the denominator. Now you split this one, you will have a plus b whole square becomes 4n square plus 2ab means 2 into 2, 4, 6, 24 into n plus 6 square gives 36 divided by 4n square plus 2 3 is 6 into 2 is 12n plus 9. Now this is the un. This is the un. Now apply the limit n tends to infinite on both sides. If you apply the limit n tends to infinite, shortcut is check the numerator and denominator. If numerator and denominator both have same degree, just you write in the coefficients only. What is the coefficient you have? 4. Here what is the coefficient? 4. So 4 by 4 you will have. Otherwise you take n square is a common. Here also highest term is common. Here also highest term is common. Getting cancelled. Then if you are applied n tends to infinite, 1 by n goes to 0. So this is goes to 0. This is goes to 0. This one also goes to 0. So 4 by 4. Any method you can apply. So the limit what we have now? 1. Is there any extreme? No. Directly you have limit is 1. Limit 1 means ratio test fails. Whenever the limit n tends to infinite un by un plus 1 is equal to 1, ratio test fails. When the ratio test fails, we have to go for Raabe's test. We have to go for Raabe's test. In the Raabe's test, we have to find un by un plus 1 minus 1 only into n. For this we have to apply the limit. If L is again the limiter greater than 1 convergent to less than 1 divergent to is equal to 1, test fails. Already we have done un by un plus 1. What is un by un plus 1 you have now? Either this one or this one. For simplification it is better. 4n square plus 24n plus 36 divided by 4n square plus 12n plus 9 minus 1 and multiply with n. That gives a Raabe's test only. So limit n tends to infinite n into un by un plus 1 minus 1 is equal to limit n tends to infinite n into un by un plus 1 is this one minus 1 is this one. Now take LCM. What will become the LCM is 4n square plus 12n minus plus 9. Now if you take in this one multiplied 4n square minus 4n square cancel. 24n minus 12n becomes 12n. 36 minus 9 will become 27. Now outside what you have? N. Now we have to apply limit. So numerator quotient this is 12n square plus 27n. Denominator 4n square plus 12n plus 9. Both have same degree. Numerator and denominator has same degree. Na? So if you are applying limit n tends to infinite, you have to take the coefficients as the common. Now that will become 12 by 4. That is 3. What is 3 here? Limit n tends to infinite n into un by un plus 1 minus 1 value is 3. Which is greater than 1. Therefore, by Raabe's test, the series is, by Raabe's test, the given series is convergent. Test for the convergence of the series 1 plus 3 by 7x plus 3 by 6 by 7 into 10 x square plus 3 into 6 into 9 by 7 into 10 into 13 x cube plus so on, where x is greater than 0. See, here they are given first term, second term, third term, fourth term, sum of the series. Are they given nth term in the series? No. So we have to find out the nth term. For this, observe the series. This is the fourth term. Na? So if you remove this last term in the fourth, last product term, the fourth, you have, you see, 3 into 6 by 7 into 10. Is it contained in second term? Yes. Previous term? Yes. Now here 3 into 7, it is containing. Now you remove 3 by 7 here, 0. Is there here? Now extra what you have? 1. So is this one belongs to enter this series to write the nth term means, is it required this term? No. So like this sometimes they will give 1 or 2 extra terms. We can neglect these terms. Then you can write the nth term freely. Now from the last term, you see, this is 3 into 6 into 9. We have to write the nth term. Third term, 1, 2, 3. Third term is containing product of 3 terms. What about the nth term? It contains product of n terms. This is a repeated series form. So now nth term we want to write now. For that, what they given? 3, 6, 9. So what is the common difference here? In each term, 3. So write down 3n. Put n is equal to 1. This is 3. Put n is equal to 2. 3 into 2, 6. Put n is equal to 3. 3 into 3, 9. Satisfied. So nth term is in the numerator, 3n. Now coming for the denominator, it is 3. You have, it is 7, 10, 13. So common difference is here 3, here 3. Okay, common difference is 3. So you have to write again 3n. 3n only. But here you see, what is the first term here? 3. But here you have 7. So add 4 for this. Now check it. Check this term is the nth term for the denominator or not. We have to verify. Put n is equal to 2. 3 into 2, 6. 6 plus 4, 10. N is equal to 3. 3 into 3, 9. 9 plus 4, 13. Yes. So this is the our nth term. Since x greater than 0 and this numerator and denominator both are positive, so this series is a series of positive terms. Now it is in repeated series form. So you cannot apply like limit comparison test, geometric series test, P series test. So we have to go for ratio test. In the ratio test you required to find the limit of un by un plus 1. So un plus 1 I want. Earlier we discussed this is repeated series form. So this contain nth term also. So 3 into 6 into 9, so on 3n. What is the next term? How you will write the next term is, common difference is what you have? 3. So add 3 for this. And for this also you add for 3. Then you will have a 3n plus 4 into 3n plus 7. Now I want un by un plus 1. Un by un plus 1, you see what is the common terms you have up to nth term. So in the numerator up to 3n getting cancelled. In the denominator up to 3n plus 4 getting cancelled. Remaining you have x to the power of n by x power n plus 1. Becomes x power n getting cancelled. 1 by x is the latter. This denominator term 1 by 3n plus 3 by 3n plus 7 reciprocal if you written 3n plus 7 by 3n plus 3 you will have. Now apply the limit on both sides. Limit n tends to infinity. This is the quotient is here n power 1, n power 1. Both numerator and denominator have the same degree. So as n tends to infinity you will get here coefficients, that is 3 by 3 into 1 by x. 3 by 3 into 1 by x. It's 3 by 3 getting cancelled, you will have 1 by x. 1 by x is a limit. Of course you can do one more thing, take n common, then you will have 3 plus 7 by n, 3 plus 3 by n cancel. As n tends to infinite, 1 by n goes to 0, so 3 plus 0 by 3 plus 0, which gives same only. Okay. Now this is L, you don't know x, but they are given x is greater than 0. If x greater than 0 means 1 by x is maybe greater than 1 or less than 1. Okay. Or else maybe is equal to also. No? So you have a different chances here. If greater than 1, what we can say, if it is greater than 1, limit is greater than 1. If less than 1, the series is less than 1. 1 by x is, 1 by x is less than 1. So by ratio test, if L greater than 1, that is 1 by x greater than 1, series is convergent. If 1 by x less than 1, series is divergent. Now x is equal to 1 maybe, na? So put 1 by x is equal to 1 in this case. That implies x is equal to 1. Where we have to substitute x is equal to 1 means entire in the given series. The given series is what here? This one. Even 3, 6, 9, so on 3n by 7, 10, 13 into 3n plus 4 into x to the power of n. Put x is equal to 1. Again what you have now? This is the our series. Just you don't have x term. Now again it is in repeated series form. Now. So what you have to do? You need to find out un plus 1. Yes, this will become a un plus 1. Now un by un plus 1 if you done, then you will have this one. So whenever the given series in repeated series form, directly you substitute x value in un by un plus 1. If you substituted un by un plus 1, you will have like a limit n tends to infinite, this n getting cancelled. Again you will have, instead of 1 by x, here we have to substitute na, x value is 1. So 3 by 3. 3 by 3 is equal to what? 1. 3 by 3 is equal to 1. That is L is equal to 1. So in the ratio test, if limit is equal to 1, what we can say? It is fails. Ratio test is fails. So we have to go for Raabe's test because the limit does not containing E. Now in the Raabe's test, we need to find n into un by un plus 1 minus 1. So that is equal to n into, what is un by un plus 1? We have 3n plus 7 by 3n plus 3 minus 1. LCM is here 3n plus 3. Now this will become 3n plus 7 minus 3n plus 3. So this 3n getting cancelled. 7 minus 3 will become 4. 4 into outside you have n. So this is 4 into n. Now numerator and denominator both have a nth term. Right. So limiting on both sides. Limit n tends to infinite, taking on both sides. Then it will happens. The numerator and denominator have the both same degree. In this case you will get the coefficient as a limit, that is 4 by 3. Or else you can take n is a common, n getting cancelled. This is 3 by n goes to 0 as n tends to infinite. So finally you will have 4 by 3. This 4 by 3 is a limit which is greater than 1. Therefore summation un is convergent. What we can say, when the limit is greater than 1, now we are doing in Raabe's test. So if L greater than 1, series is convergent by Raabe's test. So finally what we can say means the series is convergent for 1 by x greater than 1, less than 1 divergent, is equal to 1 also convergent. That is why you are written 1 by x is greater than or is equal to 1 convergent, 1 by x less than 1 is divergent. This is the Raabe's test method. Test for the convergence of the series summation n factorial whole square x to the power of 2n by 2n factorial, where x is greater than 0. You observe, in the given series they are given factorial term and it contains nth term. So this is we can consider as a un. Since x is greater than 0 and you know that n factorial is greater than 0, 2n factorial is also greater than 0. So both numerator and denominator greater than 0. Hence it is a positive. So the given series is a series of positive terms for every value of n. Now the series is containing factorial. So we have to go for ratio test. When the series is containing factorial, which method is the best method? Is here ratio test is the best method. So in the ratio test we need to find un by un plus 1. So n plus 1, un plus 1 I want. In place of n, I have to substitute n plus 1. It is not like repeated series form. This is does not containing the previous terms. So directly you put n is equal to n plus 1. So n plus 1 factorial whole square x to the power of 2 into n plus 1. 2 times of n plus 1 by 2 times of n plus 1 factorial. If you split this one, then it will become, and you can write as n plus 1 factorial whole square x to the power of 2n plus 2 by 2n plus 2 factorial. Now I want a un by un plus 1. In the ratio test now we are doing now. So that is un by un plus 1 is numerator un and denominator un plus 1. In the denominator, see, you have to simplify. This means you have to cancel the common terms. For the term n plus 1 factorial you can write as n into n plus 1 into n factorial. N plus 1 into n factorial, it will becomes n plus 1 whole square into n factorial whole square. X to the power of 2n plus 2 you can write as x power 2n into remaining x square. This 2n plus 2 I can split up to 2n factorial. So for the 2n plus 2 factorial you can write as 2n plus 2 into 2n plus 1 into 2n factorial. What purpose we are done like this? You understood, na? Because to eliminate common terms. Right. Now n factorial getting cancelled. This n factorial whole square, n factorial whole square cancel. X to the power of 2n, x power 2n cancel. 2n factorial, 2n factorial cancel. And the remaining terms are 1 by we need to write. 1 by, instead of 1 by, I am writing as a reciprocal. So the denominator will become in the numerator. That is 2n plus 2 into 2n plus 1 by n plus 1 whole square into, this is 1 by x square. Now multiply. Here you will have 2n into 2n 4n square plus 2n into 1 2n plus 4n, that is becomes 6n, plus 2 into 1 is 2, divided by n plus 1 whole square is n square plus 2n plus 1 into 1 by n square. This is un by un plus 1. Now we have to apply limit on both sides. Simply, can you guess what you will get the limit if you are applied as n tends to infinite? N square by n square. So in the numerator and denominator have a n to the power of same. Therefore, you will get the coefficients of n square in the numerator and denominator as limit. So that is 4 by 1 into 1 by x square. That is 4 by x square you will get. Okay na? So 4 by x square is limit. Limit we have 4 by x square. Do you know what about x value? Don't know. Generally here they are given, in the problem they are given x is a positive. X positive means x may be less than 4, x may be greater than 4. X square may be less than 4, x square may be greater than 4, or else x square may be 4. So the chances what we have means 4 by x square may be greater than 1, less than 1, is equal to 1. If 4 by x square is greater than 1, you can say the series is convergent. If 4 by x square less than 1, the series is divergent. Let 4 by x square is equal to 1. That implies x square value will become 4. Now we have to substitute this x square value in the given series. So we have n factorial whole square by 2n factorial into x to the power of 2n. X square is what? 4. So 4 to the power of n you have. Now you observe this is our new series. In the new series, the series is containing what? Again factorial. So go for ratio test. In the ratio test, we have to do again un by un plus 1. Instead of doing un by un plus 1, directly you substitute x square value is equal to 4 in the series. Here only you have to substitute. Here limit, in the limit. So 4 by 4 is 1 you are getting. So limit is here, finally you are getting 1. You see, this is x square is equal to 4. If you substitute, this will become 1 by 4. The quotient is 4, n square quotient is 4. So limit if you are applied, then you will have 4 by 4. 4 by 4 is 1. Again you have limit is what? 1. Therefore ratio test is fails. Here you have ratio test is fails. Is L value is containing x by e or e by x? You check it. L is what here? L is what we have? 4 by x square. It does not contain e. So go for Raabe's test. If it is containing 4e by x square or else 4 by x square into e, like if it is containing e term, you have to go for logarithmic test. But it is does not containing e, so you have to go for Raabe's test. In the Raabe's test, we need to find n into un by un plus 1 minus 1 limit for this. So first of all, n into un by un plus 1, what you have? I am written minus 1. Now what is the LCM for this? 4n square plus 8n plus 4. Now numerator minus denominator you will have if you take an LCM. Now 4n square plus 4n square plus 4n square minus 4n square cancel. 6n minus 8n, so minus 2n. 2 minus 4 is minus 2. Now this is minus 2n square minus 2n by 4n square plus 8n plus 4. Now limit n tends to infinite, n into un by un plus 1 minus 1 is equal to limit n tends to infinite, this one. Just we are taking limit on both sides. Again you observe numerator is highest degree is n square, highest term is n square, denominator highest term is n square only. So you will get as n tends to infinite limit is minus 2 by 4. Yes or no? The coefficients only, na? Minus 2 by 4. Minus 2 by 4 is minus 1 by 2, which is again less than 1. That is L is equal to minus 1 by 2 less than 1. When L is equal to 1 by 2 minus L is equal to minus 1 by 2 less than 1, that is limit is less than 1. Which method we are doing? N into un by un plus 1 minus 1 limit, na? So this is a Raabe's test. In the Raabe's test, if L is less than 1, what we can say? Test is divergent. So what we can say from this? Finally, summation un is convergent by 4 by x square greater than 1. For less than 1, divergent. Is equal to 1 is also divergent. Hence what we can say? For 4 by x square greater than 1 convergent to 4 by x square less than or is equal to 1 divergent. This is the Raabe's test.